Today, I will talk about how to enhance RFI analysis by using text clustering methods and visualization techniques. So, what is an RFI? RFI is a formal written protocol created by contractors to ask questions on design, construction, or other contractual matters. And RFIs offer insights into project history and design functionality, but traditionally analyzed throughout the manual data mining. In the literature, there are several studies focused on the manual RFI analysis, and also several studies focus on RFI text clustering to predict the project uncertainty or analyze the constructability concerns. And in these studies, the latent storage allocation, LDA, is only used, which is an unsupervised generative probabilistic model. So the main challenges are extracting hidden information from RFIs and determining how to utilize and benefit from the RFIs. Even though a few publications focus on the text clustering and visualization techniques for RFIs, they are using only a single clustering algorithm and lacking a comparison with the other methods and also different visualization techniques. So there is a need for effective RFI extraction subjects. So these subjects are generally different from the human summaries which can be found in a regular RFI document. So what concerns us is extracting all the subjects from all the RFI documents for the project. So this vision in my research is that when we extract automatically subjects from RFIs, then we can use this information to predict the potential uncertainties. So in this presentation, I'm going to focus on the first step of this vision. This study aims to identify which clustering algorithm and visualization technique are more suitable for determining the subjects in RFI data using various clustering methods like latent relay allocation, non-negative matrix factorization, or k-means, and also using the various visualization techniques like Pilot-Davis, scatter plots, bar charts, and word clouds. To validate the results, the expert interview have been conducted. So to identify which clustering algorithm and visualization technique are more suitable for determining the subjects of RFI, I analyzed 288 RFI data from an airport project, and the project unique characteristics and phases can significantly alter the terms and subjects. Because of that, actually, clustering algorithms and visualization technique in this study were compared by selecting a single project type. And also, if we take a multiple project type information, which may lead us to overlooking the project type specific information. In the methodology part, to obtain the RFI subjects, in complex structure of the RFIs, I used 280 RFIs, as I said before. Then I applied the unsupervised machine learning clustering algorithm to extract RFI subjects. And finally, subject clustering results and visualization techniques were discussed with the experts to validate the results. Initial results contain some similar subjects. The same colors actually shows the similarity of the three different clustering algorithms. For example, the LDA subject 0, NMF subject 8, and k-means subject 6 are very common because they're sharing 5 common keywords like beam, level, and etc. Of course, the keyword weights are different. And it is found that NMF and k-means are more alike. For example, NMF subject 4 and k-means subject 3 is very more alike. And although the LDA exhibit the similar subjects, it diverges with some subjects also. For example, LDA subject 8. Feedbacks were collected from 3 experts who have at least 5 years experience in the construction industry. I asked them which algorithm provided the most suitable keywords and subjects for the quickly accessing, analyzing, and responding to the RFIs. And LDA is found the most successful one because the ability to create more distinctive subjects. And also the ratings assigned to NMF and K-means are almost identical for except export 2. And these are algorithms create quite similar subjects. And also it should be noted that none of the experts gave a rating below 3, which means the overall performance of the clustering algorithms were perceived well. About the initial results, the visualization techniques, the Pilot-Davis was applied only LDA algorithm because it is specialized for this algorithm. It can rapidly filter the subjects and provide the interactive access to the users. On the other hand, the scatter plot are applied for all clustering algorithm, and it provides the insight into proximity or overlap the subject clusters. Thirdly, the word clause again applied for all the clustering algorithm, and the word clause enabled the rapid understanding of the dominant keyword in the subject and used the font size to represent the keyword weights. And finally, bar charts, I believe that almost everyone is aware, and were applied for all the clustering algorithm also. The most preferred visualization method was identified as Pilot-Davis. The experts were asked to rank 2 techniques from mostly preferred to least preferred, because the most preferred one is Pilot-Davis. And the least preferred algorithm is the scatter plot, because the lack of user friendliness about quickly analyzing the subjects and understand the topic. To sum up, the construction industry used distinctive text documents such as contracts, injury reports, RFIs, and etc. But the RFI clustering studies are very limited. The studies that cluster the RFIs only use a single algorithm and do not provide a comparative analysis. In this research, I analyzed 288 RFI using 3 different clustering algorithms and using 4 different visualization techniques. And LDA is the most preferred algorithm, and Pilot-Davis is the most preferred visualization technique. This research contributes to the limited comparative studies on the text clustering and visualization studies, and offer a valuable tool for the managers about the automatically extracted RFI subjects. And finally, this actually research contributes as being a first step to predict the potential unconformities of the projects. Thank you so much.